Okay, so Trig folks, today is the king of all programs. This will probably fill the entire board. And it's 50-50 whether I can do this without making a mistake that I have to double back and correct later. So, you might want to leave a straight line or two every now and again, just in case I end up piecing something back in, because I don't always nail this one. On my first run through, we sometimes end up with a little back and forth. But, SSA, can you give me an example of 3 facts I could choose as a group to create an SSA picture?
3, 5, 6.
3, 5, 6, yes. Somebody other than Geo, another grouping?
1, 3, 4.
1, 3, 4 would work. I'll do the 1, 3, 6. I don't know if we said that group or not, but that works too. Really, if I do 1 and 3, I could either do 6 or 4. Either way, it makes an SSA triangle. But it would be a fact group like those. So that's the 3 items that we would know. I don't know. We'll start with what? For sure.
This notebook, yeah, that one. Display.
Some kind of a display.
Yeah, there we go.
Is there one of these facts that's the easiest to ask for? Probably the angle. What do you want to call it? A. Even though Amelia's not here, we're following in her footsteps. We're going to enter the angle. Input. Then does it matter which of these we ask for? Why? Yeah, we need the opposites. We need to be careful what we ask for. Probably ask for this. Call it. So what could our sentence be? Opposite side.
Input 3. This one. Enter other one. See?
There we are. Which law is this more appealing to at first glance? Probably sines at first glance anyway, because we have an opposite pair where we know both. So we could try to follow this to find out this. Is that going to be legal or no? No, because what's the failure? Yeah, we're trying to find an angle. We don't know if this angle is acute or obtuse or what it is. All I have is A, B's, or C's. So I could send an acute or obtuse out of A, B, and C. Who knows? We have no way to know what that is. Can't do law of sines to start. Have to go with law of cosine. So how's it going to set up? Disagree. Disagree. B squared. Because these are our pair where we know them both, or have them both named in any way, we're going to have to go B squared equal
C squared.
X squared, if we're calling that X.
Minus 2 times C times X. Cosine A.
Question about that? How are we going to solve that for X?
Equals 0.
Get it to equal 0. So we have C squared
Plus X squared minus B squared.
minus the B squared, and still all the rest of that same stuff. And then how are we going to solve that for X? Quadratic. Okay, what you can't do in the middle of having one program run is stop it and run another program. Okay, because at this point, do we as the user, we're trying to avoid writing anything down. So do we as the person using the program later have any idea what A, B, or C are? No. So we're gonna have to like recreate our quadratic program inside this other program. I'm gonna veto a choice we already made. What is the quadratic, first of all, what is the quadratic formula?
Plus or minus root b squared minus 4ac over 2.
So why have we already made a little bit of an unwise choice?
Because like we use A's and
We used A's, B's, and C's, and for the quadratic part of this, we're gonna need to use A's, B's, and C's. So let's tweak the A, pick a different letter other than A's, B's, and C's.
D.
D. D. So D. Okay. Instead of B,
E.
E. So B is E. B is E. B is E. And C is F. Whoop. One. C is F. C is F. C is F. C is F. Double check. Okay, so we're good. So if we look at this, what is the A?
X. E squared.
1.
Wow.
It's the number with the x squared.
Mm-hmm.
A is 1. In our experience together, have you noticed every time x squared has been 1? If x squared, or if the x squared thing is always going to give us an A of 1, for the purposes of this program only, the quadratic formula can take on a simpler form. If A is always going to be 1, then
Get rid of all the A's.
just get rid of the A's. You don't need to have 1s go into A's and multiply things and be useless, so we can just skip that. What is the B? Which part of this is the B?
-2fx plus d.
Warm?
Plus bx. Well, I guess
Colder?
minus bx.
She said -2fx cosine D. I say almost. What is the B? How do you find the B?
Oh, is it just -2f cosine?
Correct, because the B is the stuff that's, where do we find B?
With
Oh,
the
not-
With the X, but not including
x.
the X itself. It's just the stuff, it's with the X. So when she included the X, she's looking in the total right spot, just not the X itself part of that deal. So I'm gonna go -2f cosine D. That needs to take on the name B. What button have we used before to make that take on that name? That is the store button. So we're gonna store that in B. And then who is C?
Would it just be 1?
It will not.
Would it be...
The A is with x squared, the B is with the x, what's the C?
X squared minus E squared.
Yeah, it's all the other stuff. It doesn't have any variable xy stuff on it. So f squared minus e squared.
Okay.
That is going to be stored in C. If you think back to quadratic writing day, before we had the quadratic do any math, we sorted out some problem zones. What about the quadratic can create a calculator explosion?
B squared is less than -4c.
Yeah, if b squared is less than 4c, you'd be trying to do the square root of a negative, and that can't be a thing. So we're gonna need to sort that out. If the b squared is less than 4c, do you remember what command we used?
Go to.
Go to. Pick a number, I'll just pick the 1 for you. I'll take a stroll over here. I don't know how many lines of space you need, so maybe you don't want to fill this in the notes until we get there, but this is going to be like the last group of lines. Do you remember what command we put over here to find that marker? Like I'd have to put a 1, and there's a button that marks it. It was a label. If we get over here, it means the whole thing just like blew up. So what should we do about that?
No answer.
Okay, what kind of a command?
Display.
A display to say there's no answer. These SSA triangles, is it possible they have no answers? They could also have 1, or they can have 2, where we've got the clones going that I would call them. So let me just think through and make sure we're good so far. We did the usual display input, display input, display input. We have our math set up, trying to do the quadratic formula. We picked our A, B, C. We checked to make sure we're not rooting a negative. If you are rooting a negative, get out of there. Give up, there is no answer. And all this middle stuff that's yet unwritten, what would be the case of all this middle stuff in your calculator's eyes that time? Doesn't exist. It wouldn't even look for it. It wouldn't even read it. If we're rooting a negative, it doesn't care what the process is for the other ones that work. It just kicks over to that zone. If we get to the next line, what logically does that mean about our situation? If it's even trying to read this next line.
Did it just blow up?
It didn't just blow up. It passed the test. You know, we had this test. If it fails the test, get out of there. If the calculator's even reading this, it's because it passed this test and it's ready to do the math. The negative b plus root b squared minus 4c divide 2. Are we going to want to store that? Yes, because we're going to need to use that to get more completion of triangles for us, and we called that x a second ago. This is a forced calculate or a forced punctuation mark without a doubt. What other punctuation do we need to have?
Do you need a set of parentheses at the start and then 2 before the divide?
Yes.
thing?
We'll need 1 before the divide to wrap up the ones for the rooting, and then we need another set of parentheses to do the whole top, because when we're looking at something like this, we know that they're there because of our human eye can see that, but the calculator eye doesn't see that happening, so we need a set for the whole top. Generally, at this point, we'll then throw a display up and say what the answer is. Okay. However, when you run your quadratic program, has every side been a valued side, or have there been throwaways?
Some
How are there some throwaways? Some
throwaways. Negative.
if they're negative. So we need another if. If the x is negative, how can we do that with math symbols if the x is negative?
Less than 0.
Less than 0. What if it equals 0? Can you have a side equal 0?
Yes.
In a triangle? No. So if we're less than 0, or if we're equal to 0, what should we do? Go to. Yeah, get out of there. Go to the same space or a new space?
Same.
I'd say same space. Because if the adding version of this fails and turns out negative, we still have what else to do later, the subtracting version. But if adding fails you, is there any way subtraction can help you? No. So if adding is a failure, subtracting is gonna be a failure too, just, yeah.
Correct me if I'm wrong, but I think that might be wrong because I fell into a trap 1,000 times that it automatically skips over the second part of the equation and you never do it.
If the first one fails, you don't wanna do the second one.
It automatically.
Yeah, if the adding part fails, subtracting can't work.
Okay.
If adding got you a negative, subtracting can't even be a thing. So here's what's going on. We've got our input display stuff going, we set up our quadratic, we make sure we're not rooting a negative. If we're rooting a negative, we get out of there. If we're even looking at this, it's because we know we're not rooting a negative, it's worthwhile. So we do the math. We check to see if the answer we got is negative, and if it is, we get out of there, knowing that if the adding version fails us, the subtracting is pointless. If the calculator's eye arrives here, what logically do we know at this point then? It's not negative. This is a side that is an answer of some sort. Like, we have an answer finally. So what do we want to do about that? Right. Sides. Answer or X, whatever, doesn't matter. Hooray, we have one answer. Then what?
Minus version.
Not yet. While this is fresh on our mind, what should we do?
Store it.
We did. Yeah, it's called X. We have it. We printed it. This is now known. So now what?
Should we try to find an angle?
Yeah, let's get some angle. Let's finish the triangle. Like we've got some progress. We have one fact down. We've got 2 facts to go. Let's try to finish this thing. Where would your eye naturally probably gravitate next if we just got finished talking about this? Probably to the opposite angle. Give that a name.
Why?
Why? Law of sines is tempting again in this circumstance. Can we use the law of sines to get that?
No.
No, because we'd have to know that it's
Acute.
acute. We have no knowledge of acute or obtuseness. All I have to look at is A, B, C, D, E, F, X, Y, Z nonsense. Like, there's no way to know if that's acute or not. Could you throw in a whole series of like a million ifs and like sort that? Sure, you could if you were really determined to use law of sines. But it's going to make Raina happy if we use law of cosines anyway. So we'll just go ahead and play it safe and use the law of cosines to get this y thing figured out. If we're after the y, how would the law of cosines go for us? Disagree.
X squared.
X squared. We need the y, so we need the x. So x squared, blah, 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 cosine y at the end, through the middle.
F squared plus B squared minus 2FB.
EFFE.
Yeah.
I'll put that a little bit closer next door. Gave it too much space in my budget. And again, what we're after, which letter are we after as our unknown right now? Y. Y is the one that's not known. That's what we're after. So who's got to go?
All the stuff.
Okay, what's going first?
The F and E squared? Yeah.
Say again?
The F and E squared?
Yeah, the f squared and the e squared have to go. How are we getting them out of there?
Subtract.
Subtract. So that looks like,
X squared minus F squared minus E squared.
agree. So those are out.
Divided by.
Divided by.
Negative 2EF.
-2, yeah.
Equals cosine.
Equals cosine. And since we're getting an angle, we're going to have to do
Inverse.
and inverse. So I'll step over here. Inverse cosine, x squared minus f squared minus e squared, divide. I'll go crazy negative like I always do because it's easy on this one to get our negatives crisscrossed with our subtractions, so be careful we use the right button. U, E, F. Punctuation issues on this always.
Parentheses.
Parentheses around.
Cosine E, like the.
It's going to force
Yeah,
this
yeah.
on us. We won't even have a choice.
And then
Double
after the.
parentheses before the divide. So
Um,
like a double.
disagree with a double there.
Just one parenthesis.
Just one there, but it doesn't go with that one. Add one there. That's the whole top. Like over there, there's invisible parentheses around the whole top that we need over here. And therefore, we also need them around the whole bottom. And then the one that starts for cosine needs to include like all of that stuff to go with it.
Oh, okay.
This is what you're doing.
Storing, mandatory or optional. I'd say optional, because we can use its name y to complete this, but we can also use the, we only need one more piece. Instead of using the name y and storing it, you could just use the answer button. Doesn't matter. I'm just going to use the answer button. It's shorter.
This.
Display,
Opposite angles?
opposite angle. Another display,
Answer.
answer. Then what?
On to the next thing.
On to the next angle. How are we going to get that nice and easy?
180 minus.
180 minus x minus answer. Or we could do the minus with the parentheses and the plus. We've had that discussion on some of the other ones. Then display
Other side.
other
Angle.
angle.
Display.
Display answer. And in any other program we wrote, we were done. We had like 3 things going in, we have 3 things going out. Every other program at this point, we just wrap it up and move on with our day. However, why is that not the case on this?
So I'm gonna subtract.
We still have to do the subtraction version of this formula.
What's percent?
Leave a line, leave a line. Not yet. No. We're going to need some leave some lines, but we don't need to leave those yet. We're okay. All right.
Of everything exactly except change the plus to minus.
Yeah, so we're going to go negative b minus root b squared minus 4c. Stop, divide 2. Store it. I'm going to call it x again because it still represents the same thing, right? Like these are the ones where we kind of cloned the triangles. Okay. Or we don't need anything more with this one. So if we basically ditch the old one and put a new one on top of the same name, that's harmless because we're done using that old x to produce answers. We're done printing out those answers. We're done. So this can get stored in the same spot as we're doing.
Is that negatively negative?
No, this is a minus. If we're showing up here, it means the first triangle worked out completely well. Does the second answer work always completely well? No. So what should we do about this?
If x is less or equal to 0 again.
If this new x is less than or equal to 0,
Go to 2.
go to the same place
No.
or go to a new place?
I mean, you can't.
One of them makes sense, one of them would sound dumb. Anybody have thought on why, between choosing to go here or choosing to go to a new location, which one is the better approach, considering what's already happened? So let me ask you this, does this message that there is no answer make sense at this point? No, because what? There already has been an answer. So if we go to this same spot, you're going to get a really weird conflicting message on your screen. The side is 7, the opposite angle is 30, the other angle is 70, and there's no answer. And you're like, what just happened? If this answer fails, we need to go to a new location. And I'm leaving a line here. I'm going to a new spot, call it 2. What's a more appropriate message to give the person at this
No
point?
second triangle.
Yeah, that there's like not a second triangle, or there's only one triangle, or whatever sentence you want to say. But we should tell them, hey, it's one triangle, that's all we've got to offer you. If we arrive here, if this calculator is even reading this line, what does that mean?
Both of the answers are triangles.
Both of the answers are good. Leave a line. And then what should we do?
Displace some answers.
Yeah. And then
Repeat the process.
repeat the exact process we did, starting with, which line are we on now?
Displace some.
Display side. And how much of this do we need to repeat the process? All of it. You wish, like a computer, your calculator could copy and paste. Unfortunately, you're going to have to recreate that. You're just going to have to type in all of these lines, and when you get to here, you're just going to have to retype all of those other lines. Sorry, it's just the way that goes. I'm going to need something there when we get done with that copy-paste thing. And then let me think this through and make sure I have it. I don't think I made a mistake. Other than that beginning, I let you guys pick ABC, and I should have shut that down to start with. But so we got our stuff. We get ready for quadratic. If we end up rooting in negative, we get out of there. If we get to here, it's worth trying the formula, so we do. If it's a nonsense answer, adding, we get out of there, because subtracting can't work. If we're here, it did work, so we have a process to complete the thing. Then move on to the next triangle. Try the subtract version. If it's nonsense, get out of there. I left the space. I think I'm okay. I'll need to fill that in. Repeat the whole thing. Stuff. I'm good. Alright, I think we just have to fill in the blanks. I think we're good. What's got to fill in? It's the same thing we had to fill in for the quadratic, and it's a command that I forget what it is every time I do this program.
Stop and something.
Stop and quit, something like that. Do you remember which one it was? Because you just didn't. Was it stop? Okay, where do we need some stops?
At the very bottom of the second part.
Right here I need a stop, because if I don't do a stop, okay, if I am here, what have we already printed on our screen?
The first set of triangles.
First set of triangle answers, and the second set of triangle answers, and then if we don't put in a stop, what's it gonna do?
Go to the display.
It's gonna go over here and give you the answer.
Yeah.
So we back on?
We're back on now.
Sorry, we lost some footage, so
Thanks, Chuck.
we don't know how much we lost, so we'll just have to take like a screenshot, I guess. If you just kind of pan through the screen, it's all up there. But what
Yeah, I'll
we
do that
talked
then.
about in the last minute or two, we talked about needing a stop here and a stop here, because if we don't put in those stops, it'll print all of these messages whether we wanted them or not. So we need the program to stop after these messages. And now we're trying to figure out what issue we have if our program had a first triangle and gave us all those answers, and then the program has a second triangle and gives us all those answers. Why that is not going to work out well for our human eye.
Those answers be gone.
Those answers would be gone because your screen can only fit like 8 lines. So these 6 lines would fill your screen. And then when these 6 lines print like a millisecond later in the blink of an eye, they would crowd all of those off your screen. So what we need to do about this is to display for the person that there is a second triangle. And then we have a magic key that we don't have before called a pause. So you have these 6 lines on your screen. You give yourself a message, there is a second triangle. The program pauses and lets you catch your breath while you write down the first triangle clone. Set yourself up a second triangle clone. And then how do you think you unpause it? How do you always make your calculator go? Do something. I think hit enter. You might be able to hit any key, I'm not sure, but I know hitting enter will like spring it back into action. So you're gonna have 6 answers appear in the blink of an eye. Get a message there's more coming, pause. As soon as you hit the enter key, or maybe any button, I'm not sure, you can play around with that. But as soon as you can hit the enter or whatever to unpause it, in the blink of an eye, these 6 lines appear and wipe those 6 lines out, and then you can write those down. And that, I think, will do it. So what happens next from here? Tonight, you would code this all in. I would encourage you to do that tonight and not like last minute study hall tomorrow, because it's possible this may go buggy on you. It's possible that I may have made a mistake, or we may have made a mistake. We'll blame it on everybody. It's possible there may be a small thing wrong with this. And if we don't figure that out until like late in the day tomorrow, that's gonna be a bigger problem than if we troubleshoot that in homeroom. What's happening in class tomorrow is I'm gonna give you a quiz paper that's like the quiz paper we did pencil paper style. And you'll go through and just run your programs only. No laws, no pencil, no paper, no nothing, just you run your programs. And so what you'd have to have the ability to do is look at the triangle and go, that's an SSS shaped triangle. I will run my SSS program. You run it and you just write the right number in the right spot and you move on. Some of these can still have human error because some of them we were trusting ourselves to put littlest across from littlest and so on. So you might mess that up. There are some that we've also had to recognize with our own knowledge before we started that it wasn't going to work. So there is some human knowledge required on this in addition to the programs working. So my heavy encouragement would be get a sheet that looks like this, whether that's your first review sheet we did, whether that's the optional review sheet that I left on the side, whether that's something else that looks like this, and grab one of these and run the programs and make sure that it works. If you want to spare one of these, I can give one, I can give 2, and I can make more copies if you want one. This is, I think, the bonus sheet. Some people chose to do like a second sheet of this on your own. I think that's what this is. Second thing though, we're also going to do is you're going to write for yourself an area program, which is, as much as this was far and away the hardest one, the area is far and away the easiest one. How many facts did you need to do area?
2.
Disagree?
3.
3. So we'd start off with our standard display input, display input, display input thing. And then how many lines of math are required to do the area?
What was the question?
How many lines of math will we need to do an area? 1. That's it. All we're doing is 1 line of math. Area was, I give you 3 facts, you do 1 line of math and have an area. So it's gonna be like the standard 6 display input lines, 1 line of math, and then some explanation of what you just found, that's it. So the area is gonna be like super ridiculous short. But there are, just like the other quizzes had some areas, the one tomorrow will have areas on it. So that's our job. You got it.
For clarification, where does the last column fit?
It would be after this. So we have a whole column here of writing, then we'd have this full column of writing because all of this stuff is also here. And then, so we have the pause line, we have all of these lines repeated again, a stop for that, and after the stop, then we're down that column.
Okay. I just wanted to make sure one like that and those weren't like somewhere.
No, it all is just in the order that it goes. I was just too lazy to write that all again.
So that right there is just the copy. It's not like anything up there.
This is here, and it's here,
Gotcha.
okay? I would definitely, though, again, I'll highly pitch, grab one of these sheets and try them out using a sheet, because I've had people near tears trying to make their programs run and they won't work, and they get really, it's a frustrating experience. If you find out tomorrow your programs don't work, you want to get those fixed, like, before tomorrow. Does anybody want one of these sheets for that purpose? For you, one back to Cheyenne, if you could. Is there anybody else that needs a practice go-round sheet? You want to take pictures of the answers?
Sure. Yeah, probably best.
Actually, I have a paper version of the answers.
Oh, really?
Yep, I'll give you one of those. You can just I'll put that back in my folder. And try to write the area one maybe, just so you're doing the same thing they're doing.
Okay.
And then get back and watch the videos and then write the other
Sometime
ones,
this weekend.
like as a weekend project.
Gotcha, gotcha.
This is a minus bottom. Is that X giving you?
Okay, so small change, this should not have been the X. The X was the side. We don't want an X there, we wanted the angles there. 180 subtracts angles. That should be a Y, not an X. So as predicted, I could not do this without making a mistake. It's like 50-50. Other than that, we think we're good. Okay, we can stop it again.
Oh.
Recorrection to the earlier correction. The Y was not right. The Y was the angle we were trying to find. The D was the angle that we knew. So 180 minus the D minus the answer to get the Y, and now we actually think that may be correct.
Yes,